Welcome to CognitionChunks. This is Sahelanthropus Tchadensis, the 7 million year debate, asking, what are the 7 oldest known human remains? List of the 7 oldest known human remains. 1. Sahelanthropus Tchadensis Tumai. 2. Sahelanthropus. 3. Ardipithecus ramidus Ardi. 4. Australopithecus anamensis. 5. Australopithecus afarensis Lucy. 6. Homo habilis. 7. Homo erectus. Comparison and contrast. Skeletal components. Tumai primarily consists of a cranium, whereas Lucy is known for her nearly complete skeleton. Sahelanthropus is known from a handful of bones including femurs and jaw fragments, and Ardi is represented by a partial skeleton. Time period. Tumai is dated around 7 million years ago, Sahelanthropus around 6 million years ago, Ardi around 4.4 million years ago, Lucy around 3.2 million years ago, Homo habilis around 2.4 million years ago, and Homo erectus around 1.9 million years ago. Geographical location. Tumai was found in Chad, Oran in Kenya, Ardi and Lucy in Ethiopia, Homo habilis in Tanzania, and Homo erectus in Indonesia and Africa. Posture. While Tumai and Oran are considered more ape-like, starting from Ardi, there is evidence of bipedalism, which becomes more refined in Lucy, and even more so in Homo habilis and Homo erectus. Relative timelines. 1. Sahelanthropus Tchadensis, Tumai, 7 million years ago. 2. Sahelanthropus 6 million years ago. 3. Ardipithecus ramidus, Ardi, for 0.4 million years ago. 4. Australopithecus anamensis 4.2 million years ago. 5. Australopithecus afarensis, Lucy, 3.2 million years ago. 6. Homo habilis 2.4-1.4 million years ago. 7. Homo erectus 1.9 million to 143,000 years ago. Locations and conditions. Tumai, found in Chad, cranium was in a relatively well-preserved condition. Oran, found in Kenya, some of the bones were fragmented and showed signs of weathering. Ardi, found in Ethiopia, partial skeleton but fragmented and delicate, requiring extensive reconstruction. Lucy, found in Ethiopia, 40% of the skeleton was found, well preserved but some bones fragmented. Homo habilis, found in Tanzania, fragmentary skeletal parts, including skulls. Homo erectus, found in multiple locations including Java and Africa. Condition varies from fragmented to fairly complete skulls and some skeletal parts. Present locations. Most remains are kept in national museums of the countries where they were discovered, although casts and replicas might be displayed in other institutions around the world. Interpretation from remains and surroundings. Tool use. Starting from Homo habilis, evidence of tool use becomes more prevalent. Diet. Dental morphology and isotopic analyses suggest a shift from a primarily plant-based diet to more varied diets, including meat. Environment. Surrounding sediments and flora/fauna fossils suggest a shift from forested to more open environments over time. Lessons and applications. 1. Evolutionary insights. These remains offer invaluable insights into human evolution, particularly regarding bipedalism, brain development, and lifestyle changes. 2. Climatic and environmental changes. Understanding the environments these hominids lived in can offer insights into how climate has changed and how such changes might have driven evolution. 3. Medical research. Understanding the physiology of our ancestors can offer clues to certain modern-day ailments, such as back pain linked to bipedalism. 4. Cultural and social anthropology. Although indirect, understanding the capacities of early hominids can shed light on the origins of social organization and culture. By studying these ancient human remains, we can gather information that is crucial for understanding not only our evolutionary history, but also various other aspects of biology, ecology, and even philosophy. This serves well in transmitting knowledge that adds to our collective understanding of who we are, where we come from, and potentially where we might be going, contributing to fields as diverse as medicine, anthropology, and climate science. Sahelanthropus Tchadensis, a comprehensive overview. Discovery and naming. Discovered by Michel Brunet and his team in 2001. Location: Toros Manala, Chad, Central Africa. Name origin: Sahelanthropus refers to the Sahel region and Tchadensis to the country Chad. Anatomical features. Cranium. The cranium, nicknamed tumai, is the most well-preserved part. It is adult-sized but ape-like in its small cranial capacity, 350 cm superscript 3. Facial features. Relatively flat face, non-prognathic, not projecting forward, which differentiates it from most other early hominins. Teeth. Small canines compared to apes, but larger than those of later hominins, suggesting a diet that might have been more varied than previously thought. Foramen magnum. The position of the foramen magnum, the hole in the skull where the spinal cord exits, suggests that Sahelanthropus might have been bipedal, although this is debated. Geological and temporal context. Geological strata, found in Jurab Desert sediment layers. Age, dated to approximately 7 million years ago, making it one of the oldest known potential hominins. Associated fauna and environment. The surrounding sediment and microfossil evidence suggest a mosaic environment with aspects of woodland and savanna, and it likely coexisted with various types of ancient fauna, both predatory and herbivorous. Controversies and debates. Taxonomy. Debates persist on whether Sahelanthropus is a hominin or a species more closely related to chimpanzees or gorillas. Bipedalism. Controversial due to the lack of postcranial remains, although the foramen magnum hints at potential bipedalism. Sexual dimorphism. Due to limited samples, it's hard to make definitive statements on sexual dimorphism or social structures. Current location. The original fossils are primarily stored in the National Museum in N'Djamena, Chad. Replicas and casts are available in other scientific institutions. Implications for human evolution. 1. Bipedalism. If Sahelanthropus was indeed bipedal, it pushes back the clock on when this key human characteristic evolved. 2. Diet. The tooth morphology suggests an omnivorous diet, which could have implications for understanding early hominin diets. 3. Environment adaptability. The mosaic environment suggests that early potential hominins, like Sahelanthropus, could adapt to varied environments. Scholarly contribution and public recognition. Sahelanthropus Tchadensis has been covered in several high-impact academic journals and has been the subject of various documentaries and public lectures, making it a widely recognized figure in paleoanthropology. Lessons and applications. 1. Challenging traditional narratives. Sahelanthropus provides evidence that complicates linear models of human evolution. 2. Climate and evolution. Understanding the environment Sahelanthropus lived in can offer insights into how climatic changes might have influenced evolutionary pathways. 3. Anthropological methodology. The debates surrounding Sahelanthropus also shed light on the challenges and limitations of paleoanthropological methods, including dating techniques and taxonomic classification. The discovery of Sahelanthropus Tchadensis has raised crucial questions and ignited debates that have enriched the discourse on early human evolution. Whether serving as a case study in paleoanthropological methodology or offering a tantalizing glimpse of life 7 million years ago, Sahelanthropus has significant implications across various scientific disciplines. From the towering skull of Sahelanthropus Tchadensis, affectionately dubbed Tumai, to the Omo remains in Ethiopia, each relic represents not just a fossil but a narrative, a snapshot of life millions of years ago. These remains challenge our assumptions and push scientists to rewrite the evolutionary tapestry that traces our origins. And oh, let's not forget the million-year debate. Is Sahelanthropus an ancient relative, or does it belong to another lineage altogether? The jury is still out, but the conversation is more vibrant than ever. As we wrap up, I want to thank all you cognitive explorers for tuning in and joining this fascinating discussion. Your enthusiasm fuels this channel. So, have we settled the 7 million year debate? No. But have we ventured into the labyrinthine caverns of scientific thought to ask the questions that matter? Absolutely. And that, dear viewers, is what CognitionChunks is all about, making knowledge delectable, one cognitive morsel at a time. If you've enjoyed this scholarly romp, don't forget to hit that like button and share this episode with anyone you think would be entranced by our ancestral enigmas. And if you haven't already, do subscribe for more chunks of wisdom and dashes of nerdy humor. Until next time, keep pondering, keep questioning, and never stop learning. Cheers! Was this accurate? Did GPT just make up a bunch of stuff that does not exist or does not make sense? Find out next time in the CognitionChunks follow-up.